Hi everybody, welcome back to another episode of Math with Mr. Oldenburg. Today we're going to talk about volume of prisms. We're going to introduce a new formula for volume, and you're going to see that it just basically saves a step for you. So yesterday we talked about different ways to figure out volume if we knew the object's volume but not the length, the width, or the height. We talked about words like factors, and if we remember what a factor is, that is whatever you multiply another number by to equal a product. So let's deconstruct this number. They start me with 24. Different ways to get 24? Well, I know any number times 1 is going to work. But let's think about pulling 24 apart. 24 is an even number. I can divide it by 2, right? If I divide 24 by 2, I end up getting 12. I can divide 12 by another 2 and get 6, right? So maybe we say the factors are 2, 2, and what's left over? 6. 2, 2, and 6. I also know 2 times 2 make 4. So why not do 4, 6, and 1? How about 4, 2, and 3? Because 2 times 3 makes 6. We can do this all day long figuring it. Well, actually, no, we can do it until we run out of factors. But the big part is we can find different ways of separating numbers, and any way we multiply these together, we're going to get 24. One of the things that I showed you in class the other day was we don't have to think so whole number-ish. We can also look at fractions. We know that when we multiply a number by a fraction, the value decreases. So in class I showed you 24 times 2 times 1/2. And the reason I did that was because 2 times 1/2 is a reciprocal. And we know that reciprocals always equal 1. So it's basically like multiplying 24 by 1. And it doesn't matter what number you choose as long as you take the reciprocal. Check this out. If I had 24 times 1, 2, 3, 4, 5, 6, 7, 8, 9, and multiplied that by its reciprocal, guess what it's going to equal? Oh, that's a mistake. There we go. 5, 6. It's going to equal 1. This whole thing right here, yeah, giant number, 1,456,789 times its reciprocal equals 1. So today, we deviated from the normal algorithm of length times width times height for volume. We did this all yesterday. And today we're introducing the base. I'm not going to make it all about base joke. The base is an area. It's the base area. And it's comprised of a length and a width. Because when I think about my area formula, I know area equals length times width, which, if you're looking at the two formulas I just wrote down, almost match. The only difference between area and volume is that we're factoring in the height. So what does all this mean? It means that this problem did some of the work for me already. If you notice, over here, where's my little pointer? There it is. This says the area of the base is 56 square centimeters. Now, I don't know why they didn't write it like this so you could actually see it. They're saying it's squared. Why are they saying it's squared when this is saying that it's just centimeters? Well, that's because this already took account for a length and a width. We're working in 2 dimensions, so you need the square unit. Just like when we work with volume and we have 3 dimensions, we have a cubic unit. So basically this problem's already saying that I have 56 square centimeters, which is the area. It's a length times a width. I need to bring the height into it. So 56 times 6, 336, and now I have to make sure that I write my right units. Whenever I do a volume problem, I always work with the numbers first, and then I go back and I look at my units, because sometimes I'll read feet and I'll end up writing inches for some reason. So I want to make sure that my units are always correct. So at the end, go back, look at the unit, and then make sure you're putting it in the right dimension. One other thing I wanted to talk about quickly while we're here is we said that this base area is 56 square centimeters, and it had a length and a width. What could some of those lengths and widths be? So I have to think of the end in mind. 56, how do I get to 56? Well, if I know my facts, I know 7 times 8 is 56. And these could be reversed too. Remember, your length is always the horizontal value, your width is always the diagonal, and your height's always the vertical. I could switch that length and width. It's still going to be 56. I don't know for sure which one it is, but that is a possibility. Same thing with this. Let's say 56 is an even number. That means it's divisible by 2. If I divide 56 by 2, I'm going to get 28. So maybe the length could be 2 and the width could be 28. Looking at this picture, though, those two lines look about the same length. So I'm thinking it's 7 and 8. But it's not to say that this couldn't be a possibility. And the same thing with the fraction. If I doubled 56 and then multiplied it by half, I could say that then that's definitely not it, because we're not saying you have half of a whole here. Not according to that picture, at least. So that's how you'd go about finding missing information. So this example that we had over here, they want to know what shape is at the base of the rectangular prism. They don't want to know that it's a rectangular prism. We know it's a rectangular prism. That's a 3D shape. The question specifically asks about the base. And if I look at this base, a lot of you in class said it's a rectangle. And yeah, I mean, we have a rectangular prism, and a rectangle is a two-dimensional shape. So go with that. Don't say rectangular prism. That's a three-dimensional shape. Someone said cube. A cube is a three-dimensional shape, and it also has all equal sides because it's based off of a square, which also has all equal sides. It's not a square because we've already said that with the base area of 56, we had two different values. So it must be a rectangle. A cereal box measures 6 inches long, 2 inches wide, and 10 inches tall. They say that the area base is 12 square inches. Now, a lot of kids, when you go to figure this out, are going to try to use all 4 of these numbers. There's no need, because, first of all, volume can only have a max of 3 numbers to be placed in. But if I look at what I just underlined, 6 inches long, 2 inches wide. This is an area of 12 square inches. Well, area equals length times width. And if I fill in what these words are associated with, they already did it. So all I have to use is the 12 and the 10. And then I have inches to the third power. And I had to remember, I used the formula, not area, I used volume equals base times height. I could have also solved it with volume equals length times width times height. I had the numbers for that. It didn't matter which way I went about it. The matter that they were looking for was if I was smart enough to use the correct numbers and not all of them. Also, if I was responsible for drawing this picture, I need to look at the numbers they gave me. So they gave me a 6, a 2, and a 10. Well, 10's the largest number, so it better be the largest looking. And they said it's 10 high, so I'm going to draw a really long line. 6 inches long, so make sure that's long, and then 2 inches wide, so I'll draw that. All right, finish my first rectangle, and then make sure you label 10 inches, 6 inches, 2 inches. And now if it was laying down, I'd probably say you're wrong, because that would mean the length is 10, not the height. All right, and then really quick, how to solve these. They're giving me my base area. They've already done length times width, so it's just 18 times the height, which is 7. 56. Don't forget to regroup. When you bring that 5 up, you need to add it back. Some people weren't doing that today. 7 times 1 is 7, plus 5 is 12. I have 126 what? Feet, and not squared. 2 dimensions plus 1 dimension, 3 dimensions. Over here, 24 yards squared. They already did that work for me. Thank you. Times 9. 9 times 4 is 36. 9 times 2, 18, plus 3, 21 yards. Thank you. Squared, cubed. There you go. It's how we use base area in volume. Hope that helped.